This lesson is an introduction to logarithms. A logarithm is an exponent. In order to understand a logarithm, we start with the exponential equation, y equals b to the x. A logarithm is the inverse of the exponential equation. So we will swap the x and the y and get x equals b to the y. This is more commonly written as y equals log base b of x. So a log is an exponent. The answer to a log is the exponent. The y here is the exponent. Example 1, log base 2 of 32 equals 5. So to say that, log base 2 of 32 is 5. What it means is 2 to what power is 32? Well, the answer is 5. Let's practice evaluating logarithms without a calculator. Number 1, log base 5 of 25. So in order to do that, we want to set that equal to y. And we want to rewrite this as an exponential. So we're going to take 5 to the y power must equal 25. So again, that's 5 to what power equals 25. Well, we know that is equal to 2. So the answer to number 1 would be 2. Number 2, log base 3 of 27. So we set that equal to y. Rewrite as an exponential. I call this the log loop. So we start at the 3. 3 to the y equals 27. Write as an exponential equation. And we think 3 to what power is 27? Well, the answer is 3. The next problem is a little trickier. We have log base 4 of 1/16. So we will write that as an exponential using the log loop. 4 to the y equals 1/16. If this is not as easy to do in your head, we can rewrite as 4 to the y equals, well, 16, that's 4 squared. And to move that to the top of a fraction, we use a negative exponent. So that would be 4 to the negative 2. And since our bases are the same, the exponents are equal. So y would equal negative 2. This log is equal to negative 2. Number 4, log base 1/2 of 2. Set that equal to y. So 1/2 to the negative 1 power would equal 2. Number 5, 1/3 to what power equals 1/9? Well, that is to the second power. 1/3 squared is 1/9. Number 6, log base 7 of negative 49. Let's set that equal to y and try our log loop. 7 to the y power equals negative 49. And what could y be? Well, we could try 2, but 7 squared is 49. And y equals negative 2 would be 1 over 7 squared. That would be 1 over 49. It turns out there's no value of y that we could have equal negative 49. So the answer to this log is undefined. The next topic are some logarithm corollaries. A corollary is simply a theorem that follows immediately from another theorem. Let's look at the first log property, log base b of 1. Well, let's just plug in some values of b and see what we get. So let's first choose b equals 3. Log base 3 of 1 would be 0 because 3 to the 0 power is 1. Let's plug in another value for b, say 7. Log base 7 of 1. Well, that would also be 0 because 7 to the 0 power is 1. Following this pattern, we see that log base b of 1 will always be 0, and that is because of the log loop. B to the 0 power equals 1. Remember, the answer to a log is always an exponent, and we see that b to the 0, 0 is our exponent, is equal to 1. We'll do the same with the next properties, log base b of b. Let's say b is 3. So log base 3 of 3, well, that's equal to 1 because 3 to the first is 3. Let's say b is 7, log base 7 of 7, well, that's 1 because 7 to the first power is 7. We see that this will always equal 1. And that's because, again, using the log loop, b to the first power is equal to b. The third corollary, log base b of b to the x. Well, let's choose b to be 3 and x to be 2. Log base 3 of 3 squared, well, that 3 squared is 9. And we know 3, using the log loop, 3 squared is equal to 9. So the answer to this log would be 2. Let's try one more. Let b equal 2 and x equal 5. Well, 2 to the 5th is 32. And we know that 2, here using the log loop, 2 to the 5th power would give us this 32. So we see the answer is 5. So in general, log base b of b to the x would equal x. And using the log loop, we see that b to the x power equals b to the x. The last one is the same idea. The log and the exponential undo each other, so b to the log base b of x is equal to x. Finally, let's look at the graph of the logarithm function. We will switch over to Desmos now. In the first table, we will graph the equation y equals 2 to the x. I've chosen several values for x. We'll plug those in. Start with negative 2. 2 to the negative 2 is 1 over 2 squared. So we have 1/4. 2 to the negative 1 would be 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 squared is 4. So you see here we have the graph of y equals 2 to the x. Now let's find the inverse of that. Let's switch the x and the y here. So we're going to graph now x equals 2 to the y. Well, when we switch the x and the y in the equation, we are graphing the inverse. So in our table below, we will simply swap the x and the y coordinates. So when x is 1/4, y will be -2. When x is 1/2, y is -1. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. And you see the graph, x equals 2 to the y. Now, the notation we use for this, we don't usually write this. We usually write with the y alone. We write this purple equation here as y equals log base 2 of x. And you can use the log loop to verify that this is the same as x equals 2 to the y. So we have 2 to the y is equal to x. So this answer to the log is the exponent. Up here, the y is the exponent. Now we see the graphical relationship between the exponential and the log function, as we know, is the reflection over the line y equals x. Log base 2 of x is a parent function. You may record these notes. In general, y equals log base b of x when b is greater than 1. The domain is 0 to infinity, not including 0. The range is -infinity to infinity. The x-intercept is 1, 0. And the asymptote is the vertical line x equals 0.